Okay, higher derivatives.
We have to write this out.
If you like to take notes, write it down.
Use your brain.
If you want to print it off at home, print it off at home. If you want to take a movie of it, although there is one being recorded, then you can do your own. In these technological times, we do not have to be 15th century monks copying down manuscripts.
Following the chase of the Rangers won. I mean, Lightning definitely won that trade. Yeah, did. A prospect, the second round and fifth round.
Beware this records. If it takes out you swearing, I'm not editing that out.
Okay.
All right? We'll just make a note of who it is. So if f is a differentiable function, then its derivative, f prime, is also a function. Right? We know that it's a function. So f prime may have a derivative. Let's just say may have its own derivative. F prime prime. Or f double prime. Which is how we're going to denote the second derivative. So that's called the second derivative. So let's talk a little notation-wise. What else? How else may we see this written? So we may see it done this way. D by dx of dy by dx, and that's written as such. D squared y over dx squared, so that denotes the second derivative as well. Or we might see f double prime of x. And we might see it with the capital D notation. So d squared f of x. Not really squared, right? d2 f of x. So we think about what is the second derivative. Well, the first derivative is a rate of change, right? It's rate of change of some function. The second derivative is the rate of change of the first derivative. So to put that into more concrete terms, if we think about the position function, right, then we know that the rate of change of position, right, change in position over change in time, is velocity. If we take the velocity function and we do a change in velocity over change in time, what do we get? Acceleration. People have done some physics, right? So we get acceleration. So, yeah, make a little note of something along those lines. So, so the second derivative is the rate of change of the rate of change. This one here being the first derivative, right? And then it's the rate of change of the first derivative. It's called second derivative. So to relate that then, So if s equals s of t is the position function of an object, then v of t is s prime of t, or ds by dt. And the instantaneous rate of change of velocity is called acceleration. Give me a sec, if you want to copy that. If you want to be the old 15th century monk. Yeah, no, that's fine. I mean, sometimes you like to have this, right? That's cool. So, you got that? Looks like. The instantaneous rate of change of velocity with respect to WRT, with respect to time is called acceleration. Always something I like to experiment with in my car. And so A of t is v prime of t, which is s double prime of t. Right, so the second derivative of or in Leibniz notation, A is dv by dt, or d squared s over dt squared. So, let's do an example of this then. Excuse me, give you a function. Give you a second. Then I'll give you a function. Go to a new page. Okay. Actually, hang on. I'll give you some. Okay, so let's say we have the position of a particle. So the position is given by t cubed minus 4t squared plus 8t, where t is measured in seconds and s in meters. Meters. So velocity. Well, velocity is the derivative of position let's do this. So v of t is, and you can do that one, right? Easy peasy now. 3t squared minus 8t plus 8. The acceleration is the derivative of the velocity. Okay. Okay, so a of t is equal to d squared s dt squared, which is dv by dt, which is 6t minus 8. So if you needed to find the acceleration at a given point in time, then you would just plug that in here, right? What's the acceleration at 3 seconds? Well, it would be a of 3, which would be 18 minus 8, or 10 meters per second, or meters per second squared, right? So maybe I should graph these. Let's graph these. So t cubed minus 4t squared. So we'll go y equals t cubed minus 4t, oh, there's a squared in here, squared, plus 8t, right? And let's take a look at that, and let's move this over, because it doesn't make much sense to... and then we've got the derivative, so that's 3t squared minus 8t. And then we've got the second derivative. Oh, right, sorry, plus 8. And then we've got 6t minus 8. Okay, and I don't know, I don't see anything terribly useful here, but as it's climbing, and that is, we have sort of a part there. Should have picked a better function that had a few little, yeah. So, yeah. Forget that. There is a third derivative. Sorry, is that third? No, second derivative. Yeah, there's another derivative, which is the rate of change of acceleration. Do you know what that's called? It's called the jerk. Because if you think about it, if you're riding on a ride, you've ridden on that one, Knott's Berry Farm, that accelerates, you use this magnetic thing, just all of a sudden you're going, it's like, the jerk. Yep. That's why it's called the jerk. If you accelerate really fast, you feel yourself being pulled back in your seat. Right? So that's the third derivative.
So would that be
So
like
would it be a
6
force going the other way?
meters per second cubed?
It would be 6.
Meters per second cubed?
Yeah, I guess. And it's the rate of change of acceleration, right? And then, so let's just talk about a third derivative. So the third derivative, not the movie. So third derivative is denoted by f triple prime. It's the derivative of the second derivative, right? You got to work them out one at a time. So it's like f double prime, right? Second derivative prime, like take the derivative of the second derivative. And is the slope of the curve so it's just the slope of the second derivative, right? Sorry, it's rate of change of that. Can be denoted y triple prime, f triple prime of x, the rate of change of the second derivative, Okay, so it could be denoted like that. When we get to higher derivatives, this is actually the title of today's thing. When we go above 3, we stop with the primes. Right? So you have 4, you'd be counting prime, right? How many primes are there? And it just becomes, so notation for higher derivatives than that. So the notation okay, so fourth and beyond, you use y and then in brackets and, so not without the brackets, right? Otherwise it becomes like y to the fourth, and then that would just be really confusing. So it needs to be in brackets. So the fourth derivative would be y bracket 4 bracket equals, or f bracket 4 bracket, etc. In this notation, it's fine, right? I mean, d4y, dx4, and in this notation also fine. Those are more specific derivative notation, whereas y to the n could be y as a power of n. Okay, still writing. Let's do this one. So if f of x is 1 over x, find the nth derivative of x. Well, it means we've got to come up with some kind of a general term, right? And if we're going to do that, then we should just start off by looking at the first few terms of this. See, well, what's f1, or f prime, what's f double prime, what's f triple prime, and so on until we get to 4. So f of x is x to the negative 1, right? I mean, first we just need to write that notation, and then we can do f prime of x. So what's f prime of x? Negative 1x to the negative 2, right? Which is negative 1 over x squared. But if I'm going to go on, I want to be looking here, not necessarily here, right? I mean, because this I would have to put back to this. So f double prime is equal to what? 2x to negative 3, right? So it's like negative 1 times negative 2. Oh, well, let's change the order of that. Okay, that would be equal to 2 equal to 2x to the negative 3, or 2 over x cubed. What's f triple prime? So I'm just going to leave this expanded, right? So we're going to say it's negative 3 and that gives me what? Negative 6 x to the negative 4. What's f4? Negative 4. Okay, at this point I'm going to stop sort of simplifying that, right? What's F5? All right, so you ever seen this pattern in numbers before? 5 times 4 times 3 times 2 times 1? And factorial. Well, okay, so we need some negatives, right? How many negatives do we need? So, wait, pattern. We're doing F1. So how many negatives? I have one negative here, right? F2. So I need n negative 1s. Negative 1 to the n. Now all that's going to do is just flip the sign back and forth, right? But that's what we need, right? I mean, we need, if I'm doing an odd derivative, I need an odd number of negatives to get a negative term. If I'm doing an even derivative, I need an even number of negatives to get an even term. Okay? Then, what's this number? How does this relate to this?
Negative n minus 1.
Anyway, that's what makes things difficult.
Oh.
It's just n factorial, right? Well, we forgot factorial. And then what do we have? X to the power of? Negative n minus 1, right? That's right. So, okay, well that works. So let's try that with the 5, right? So I've got 5 negative 1s. 1, 2, 3, 4, 5. Okay, that's good. I got 5 factorial, 5 times 4 times 3 times 2 times 1. Got a 5 here, I put a 5 here, I got negative 5 minus 1 is negative 6. Okay, that sounds pretty cool. Okay, let's clean it up a smidge. Oh wait, that should be n plus 1, right? Plus 1. Make everything negative. Then move it down below. Good. Okay, cool. Wait, still writing? Well, let's tie this in with yesterday, and we will do. And this is also, I think, number 5 on your assignment. So, the assignment, right? So you can do the first 4 questions as of yesterday. You'll be able to do the 5th question as of today, next Thursday. I will help you on those 4 or 5 questions till the end of this week, but not next week. Right? So in other words, you got 2 more days. If you want to ask questions about the early questions, you have 2 more days to do it. Okay. So next week, you're going to be on Monday, 0 yeah, too bad. Okay. And then we will be learning the rest of the stuff for you to be able to do the rest of the assignment, up to a couple of days before it's due. So, you should be getting done 1 through 4. Today, 5, and then take it from there. Ah. Okay, so determine y double prime, the second derivative, if x to the 4th plus y to the 4th is equal to 16. So we're going to have to use implicit differentiation here, right? And we're going to have to find y prime first, right? Can't do anything. Can't get y double prime without getting y prime. So y prime is equal to Sorry, not y prime is equal to. So we take the derivative of both sides with respect to x, right, which gives us 4x cubed plus 4y cubed y prime equals 0. Okay, so that's just yesterday's stuff. So y prime is equal to, so we move stuff over. All right, so move that over, get negative 4x cubed, and divide by 4y cubed. And we get negative x cubed over y cubed, right, after simplification. So now we have to take the derivative of that. Quotient. All right, so yeah, all right, yeah, let's just write that up here. So we need the derivative of negative x cubed over y cubed, which is the negative of, okay, so it's, do you like f and g? So if we say like fg, so there's g times f prime. So y cubed times, well, let's be explicit here. D by dx of x cubed minus, clear that out, load it down, minus x cubed times d by dx of y cubed.
Isn't it the second term that gets derived?
Well, this is the first derivative, so I'm taking this is y prime.
No, I know, but isn't it the f? Like, isn't it gf prime minus fg prime?
So g, f prime, derivative of x cubed, minus f,
Right.
g prime, not yet done, but d by dx of the bottom, right? So denominator times derivative of the numerator minus numerator times derivative of the denominator over denominator squared. Okay, so now keep going. So we got the negative, we got y cubed, that's easy, right? 3x squared. So y cubed times 3x squared minus x cubed times 3y squared, y prime. Yeah? Negative x.
Yeah.
Well, the negative's out front. I just got the negative sitting out front. This negative here, that's here. Yeah, I'm not putting it with. Just think of it as a constant and throw it out front, do the derivative. Okay, so there's your negative, right? Then we're just doing this, right? Keep life easy. I mean, you get the same result doing it the other way. Be fine. You just have to keep your signs straight. But I do have the negative. It's just out front. Well, we know what y prime is, right? It's right here. What y prime is negative x cubed. This is y prime. So in here, we're going to substitute y prime, what we know, the expression, right? Negative x cubed over y cubed. So let's do that. Must extend page. Okay, so that's the negative of, hang on, negative. No, well, while we're doing this, let's write this. So 3x squared y cubed minus 3x cubed y squared negative x cubed over y cubed. All over y to the 6th. Okay. Can I select? How do you select? Select. Okay, let's see if I can do this. Control C. Page. Control V. Nice. Good. So, how much detail do you want in cleaning this up, right? So let's do a reasonable amount of detail. We'll go through them. So let's do this. I'll go across. So we got a negative. We got the 3x squared y cubed minus, okay, oh, wait, it's going to be plus, right? So minus times minus will be plus 3x to the 6th over y, right? Multiply these together. You get plus 3x to the 6th. I got a y squared over y cubed, so plus 3x to the 6th over y. And let's go times 1 over y to the 6th. Okay, because we get that y to the 6th in there to deal with as well. So to add these two guys, I need to put this over y. So this will become a y to the 4th, and then we'll get a y. So, okay, let's do that. So we'll get negative, okay, 3x squared y to the 4th plus 3x to the 6th over y, right? Which now puts us one step away from the answer. Yeah, we're going to have with y to the 7th in the denominator, right? So it's the negative, well, okay, two steps away. 3x squared y to the 4th plus 3x to the 6th over y to the 7th. Common factor of 3x squared is going to come out in top. So we just got one more negative. So we got 3x squared, common factor, y to the 4th plus x squared. Or sorry, y to the 4th plus x to the 4th over, oh wait, we know what this is. Y to the 4th plus x to the 4th. It's 16. Right? Wow, okay. So, I'm going to come across. So it's negative 3x squared, and that's 16 over y to the 7th. So it's negative 48x squared over y to the 7th. So a couple interesting things happened, right? So we did an implicit differentiation. We got y prime. We substituted, then when we did the second derivative, we got a y prime in that, and we said, but we know what y prime is. We just found out what y prime is, so we substituted that in. Simplified. Then we factored, and we said, well, now I've got this expression. That's just my original expression, right? And so that is equal to 16. And so we go throw the 16 in, and there we are, right? So much simpler than you might have expected. There's no y primes in there, so it's just negative 48x squared over y to the 7th, right? Which is the rate of change of the rate of change of the original x to the 4th plus y to the 4th equals 16. Okay?